Think about trying to help a student with a math problem over the phone. Your first challenge is to make sure you are both talking about the same thing. You might try a couple of things to get there. You might say things like, use the order of operations rule to solve for the numerator and denominator, where 1 over x added to 1 over y are divided by y minus z. Or you might say something like 1 over x plus 1 over y divided by y minus z. Both those methods communicate the same thing. The first method tries to communicate the mathematical meaning, numerator, denominator, add, divide, but it leaves the notation up to the student. And the second method tries to convey the notation by itself and leaves it up to the student to interpret it, to know that this line means divided by, for example. These are the two methods by which MathML can convey information to software that supports it. These two styles of encoding are called content encoding and presentation encoding. Conceptually, presentation encoding is a little like HTML for math. Once the MathML library is loaded, it has tags that will format math with great precision. The output will still be sort of formatted text and portable in the same way as formatted text, but it will have all the spatial relationships and the special characters and such that are required for mathematical notation. Content encoding, on the other hand, communicates the mathematical meaning intended and allows the formatting to be controlled by whatever software is reading those tags. For example, instead of specifying spatial relationships in rows or columns in specific characters like the plus sign or the minus sign, it has tags for math concepts for functions like plus and minus, add, subtract, that kind of thing. The software that reads this encoding can now display the math according to its own rules for notation. Again, the output will be just as portable as formatted text. An alternative to MathML that's in fairly common use is called LaTeX. It's spelled LaTeX, but it's pronounced LaTeX, not latex. LaTeX is a purely notational encoding, and it actually may be more familiar to you than MathML. When you're in MS Word and make notations like n caret 2, n to the second power, right? And you use a slash for divide by 4, so n to the second divided by 4. You're using at that point LaTeX notation, which employs common keyboard characters. LaTeX notation. LaTeX also has libraries of other mathematical notation, all of the Greek characters and subscripts and superscripts that math requires. MathML and LaTeX are about encoding the structure of mathematical expressions so that they can be displayed, manipulated, and shared. A carefully encoded math expression using either of these methods can be evaluated in software by browsers. It can be edited in word processors. It can be printed. It's very portable. So these are what other software vendors are adopting, and certainly what HMH will adopt in order to publish math programs online. And this brings us to the end of our brief intro to MathML and LaTeX. Thank you.